grab some separate parts from different lesson plans and kind of mash them together. So I'm going to do first just a quick demo on some various techniques that we can use to solve quadratics, and then we'll follow that up with using those techniques to help graph quadratics, right? So typically how I begin my classes is first we'll start with just questions from students. We sometimes spend like 5 or 10 minutes talking about that, depending on how in depth we want to go. After that, we'll kind of recap the previous day, the previous lesson, depending on if we're doing a Monday, Wednesday schedule or back to back. And we'll just kind of remind ourselves what we're working on, and then we'll kind of jump in to what we're doing right now, depending on if there's some motivating examples or not, right? So something that we might do right here is we might just start with the definition of a quadratic, and if we haven't seen anything like this before, we're just going to deal with it in standard form. We're going to define a quadratic expression to be of the form ax squared plus bx plus c, where a is not equal to 0. I'm going to try to treat y'all like my students and ask y'all some questions, all right? So why might we not want a to be 0 here?
Because they're not quadratic.
Yeah, then it wouldn't be quadratic, right? Then this first term would fall out, and we'd just be left with bx plus c, which is what type of expression? Linear, right? So we've learned about those. Hopefully at this point we've done some graphing on those and learned how to graph those properly. But now all we're doing is we're going to be adding an extra term, x squared out here times some constant. We're going to be looking at how we can solve some of those. Now, we could be missing some terms on this b or c or this bx or c term, but it's important that we have this ax squared term because that's what makes it a quadratic expression, right? So let's look at some simple techniques for how we can solve these guys, okay? First off, we're going to deal with this equation right here. 1/4 times x squared is equal to 9. Now, for some quadratic equations, we are able to treat them much like we are with much the same tools that we used whenever we were using linear solving techniques. So for this one, it kind of looks a lot like whenever we were solving for linear equations, and we can employ similar techniques. So just looking at this, if we were to treat this x squared as just an x, what would be our first step for solving this guy as a linear expression if we were treating him as such?
Get it by itself.
Get it by itself, right? Whenever we're trying to solve for something, we're trying to isolate the x variable, right? So what we're going to do right here is we would like to get x by itself. What's a good way to do that, looking at this?
Divide by a fourth.
Divide by a fourth or multiply by 4, right? You can kind of go either of those routes. So we'll go ahead and divide by a fourth, or let's go ahead and do multiply by 4 since it's the same thing, right? Dividing by 1/4 is the same as multiplying by a 4. So we'll do 4 times 1/4 x squared is equal to 4 times 9. Remember the golden rule of equations, as long as you do it to one side and also do it to the other side, then we keep that equality, right? After we do that, we get the simplification to just x squared is equal to 36, all right? Now at this point, it might be helpful to remind ourselves what the squared operator means, right? What does it mean when I'm squaring something?
Multiply itself.
Multiply by itself, is that what you said?
Yes.
Yeah, right? Would we agree on that, I think? Whenever we're trying to square something in general, right, what we're doing is we're saying that this is just x times itself x, right? So what we're asking here is we're asking what number multiplied by itself is going to give me 36, right? So we have an operator for that, but before we go ahead and write out what that operator is, what types of numbers could we put in here to make this equation true? What kind of numbers could we substitute in the correct term here?
6.
6 is one of them. 6 is the only one. We should have one more, right? What's the other one? Negative 6 as well, right? Whenever we're taking squares of numbers, we have to remember that they have that negative counterpart that can also square, right? So whenever we do the square root operator, which is going to be the opposite of the square operator, we have to remember to take the positive and the negative branch of that, right? So what we do is we're going to take the square root of both sides, and we got to remember that we have to do the positive and the negative square root of 36. And as we've identified, that's going to be both plus and minus 6. So the two solutions to this particular quadratic are plus or minus 6, right? Simple enough. Is everyone following so far?
Mm-hmm.
All right, wonderful. Let's keep going. Now, something that's going to help us out a lot whenever we're dealing with quadratics is going to be factoring quadratics into typically two multiplicants. The reason why is we're then going to invoke this thing called the zero product property. Basically what this thing says is if I have two things multiplied by each other, a and b, and they're equal to 0, then that means that either a has to be equal to 0